Alright, hello everybody, and today I'm going to be introducing the idea of radians. And what exactly are radians? Well, radians are just another way to measure angles right here. So we used to think about angles in terms of degrees, where we defined a full revolution as being 360 degrees. So let's take this scenario right here. We have some person standing in the middle here, and we have another person who's walking around in a circle like so. And let's say that person starts at some point here. Let's call this the start. And he's going to end somewhere along the circle. So this person's just going to simply walk around and end somewhere along the circle. So if we're using degrees to measure this angle right here, we're asking the question, how much did this person have to rotate his head in order to keep track of this person who's moving along the circle right here? And let's say this person had to turn his head 45 degrees. But instead of considering how much this person has to turn his head, sometimes it's better to consider how much this person right here has to walk around the circle to make this angle right here. And that's exactly what radians are. Instead of taking a look at how much this person has to turn his head, we're instead taking a look at how far this person has to walk along the circle right here. And the circle, we just defined it as having a radius of exactly 1 unit. So if a full revolution around is exactly 360 degrees, as we defined it in degrees, then if this person walks all the way around the circle, he's going to make the exact same angle. But we want to have a look at how far he had to walk. Well, we know the formula for the circumference of a circle is exactly 2 pi r, and just plugging 1 into this radius right here. In order for this guy to walk a full revolution around the circle, he'll have to walk 2 pi units. And the units we're using, they're going to be called radians, so we're just going to denote it by rad, like so. So in degrees, if this guy had to track the movement of this other person walking all the way around the circle, he'll have to turn his head 360 degrees. But in radians, he'll have to turn his head 2 pi radians, because 2 pi is exactly the distance that goes all the way around the circle. So how about this 45 degrees right here? How can we express 45 degrees in terms of radians? Well, first of all, what do we know about this 45 degrees right here? We know that it's exactly 1/8 of a full revolution. So if we take 45 and divide it by the whole entire 360 degrees, that's exactly 1/8, like so. And if this guy is turning his head 1/8 of a full revolution, that means this person walking around right here must also be walking 1/8 of a full revolution around. So in radians, instead of walking 2 pi radians to get all the way around, he only needs to walk 1/8 that distance. So if we take our full entire revolution and multiply it by this 1/8 right here, we're going to get pi over 4. And pi over 4 is exactly this distance right here that this person had to travel to make that angle right here. So 45 degrees is the equivalent of pi and 4 radians. Let's say this person ended up over here, and in degrees we know that this person had to turn his head maybe 120 degrees. Well, what exactly is that in radians? Well, radians, we're asking how far this person had to travel to walk all the way around over to this position right here. Well, we know 120, that's exactly 1/3 of a full revolution, because if you take 120 divided by 360, that's exactly 1/3. So that means this person had to walk 1/3 of the full revolution round to get to this position right here. Well, we know a full revolution is exactly 2 pi, so we're going to multiply 2 pi by that 1/3, and we're going to get out the end 2 pi over 3. So 2 pi over 3 in radians is the equivalent of 120 degrees. And you can use that idea of this person walking around the circle to convert from degrees to radians. Radians are just simply another way to look at angles. It's just another perspective on it. And in fact, it's more useful than using angles, because the formulas that involve radians are a little bit nicer than formulas involving degrees, because it's nicer to have rotations of 2 pi instead of 360 degrees. But yep, that's pretty much it, and I'll see everyone next time.